So we welcome all. This is the fourth day, second speaker, very big name in the academia, Dr. Aditya Ghosh has joined with us. So we welcome you.
Thank you.
It is our honor that sir is here with us. So little bit information about the sir. Sir, Dr. Aditya Ghosh is a very big name in the academia. He holds PhD MSc degree in computing science from the University of Alberta, Canada. Sir has also spent his PhD candidature at the Beckman Institute, University of Illinois at Urbana. He has done BE in computer science engineering from Jadavpur University, Kolkata, India. Sir has the University of Alberta. He received the Jeffrey Sampson Memorial Award. His research has been funded by the Australian Research Council, the Canadian Natural Sciences and Engineering Research Council, the Japanese Institute for the Advanced Information Technology, and the various Australian government agencies. Sir's research paper has been published in the top venues in the Services-Oriented Computing ICSOC, Software Computing IEEE Transactions on Software Engineering, AI Intelligence Journals, AAAI, AAMAS, ESCAI. Sir has been invited speaker at seminar series in Germany and the BANF International Research Stations in Canada. Sir has been a keynote speaker at several conferences, program and journal chair of several others. He is a senior technical advisor to several innovative companies that apply AI techniques, enterprise computing, business process management, industrial optimization, both in Australia and Canada. Sir has been served as the assessor for the Australian Research Council also. Dr. Aditya Ghosh is a professor of computer science at the University of Wollongong as a director of the Decision System Lab. He holds a team conducting research into the service science, business process management, software engineering, optimization, draws inspiration from the cross-fertilization of ideas from his predecessors. Sir has so many qualities, a day would not be enough to describe his personality. I am highly grateful to invite the eminent personality, Dr. Aditya Ghosh. Sir, it is our honor to call you. Sir, please take the command in your hand.
Okay, thank you, Dr. Sapra. That's very kind of you to say those things. I'll try and share my screen now.
Sure, sir.
Okay, so I don't have a lot of context on what the focus of this faculty development program is, but I understand that it's broadly about AI and related topics. So I thought I would talk about some of the work I do, maybe the area that has kept me most busy in the last 5 years, which is the application of AI in business process management. So the photo you can see on the slide here is a shot of Wollongong from the waterfront. Wollongong is a southern suburb of Sydney, so we are about an hour south of the Sydney International Airport. This is our campus. The Decision Systems Lab, which I lead, has been in operation for almost 25 years. We work, as Dr. Sapra already mentioned, in the area of business process management, services, requirements engineering, but mainly we are an applied AI group. So what we do is the application of AI in a variety of settings. The kinds of AI we look at includes knowledge representation and reasoning, agent technology, constraint satisfaction and optimization, and also these days machine learning, as many people do. A lot of this is where our lab is located, this building here. A lot of the work we do is also in the area of clinical informatics, which is where we work with radiation oncologists from our local health district, but also one of the major hospitals in Sydney, which is called Liverpool Hospital, and also a major radiation oncology clinic in the Netherlands called Mastro. And the main kinds of work we do with them is data analytics for clinical process understanding, clinical decision support, and so on. So we have an entity called the Center for Oncology Informatics where we do some of that work. A lot of the work we've done is with larger businesses in this space, and I think Dr. Sapra has already covered it. We have a lot of work these days with defense, with sometimes in collaboration with companies like BAE Systems, which is a major British defense contractor. More recently, we are working peripherally with Lockheed Martin, which is a major American defense contractor. And a lot of the work is with Australia's Defense Science and Technology Group, which is approximately similar to India's DRDO. So let me now motivate why I think this is an interesting topic for the audience here to consider. So what I'm going to talk about is the application of AI to business process management. So why is business process management important? The simplest explanation is by way of an example. So the world's second largest software company, which is SAP, is essentially a company that sells software that supports best practice business processes. So in fact, a lot of the work that has happened in the area that is now called BPM, or business process management, is because of sponsorship from SAP, and a lot of that ecosystem has been built around SAP's activities. So a lot of the work that happens in this space is also European, but these days, of course, everybody else has also, a lot of other entities have also gotten into the game. So there is substantial work on business process management in East Asia, in North America, not so much in India, but there is some. And a lot of the work that happens in India happens in corporate R&D labs such as IBM Research and so on. So a lot of the work that happens is in the area of modeling business processes, because once you model a business process, most times the modeling language is also, in software engineering terms, it's an executable specification language, so you can execute a model. So the most commonly used notation is something called BPMN, which stands for Business Process Model and Notation. It's standardized by OMG, which is the Object Management Group, which is also the body that standardizes a whole bunch of other standards that are routinely used in computer science. The antecedents for some of this work sits in a notation called Petrinets, which is very, very old, originally invented by a German chemical engineer. The antecedents also go to something called process calculi. EPC chains was the notation that SAP used to use internally, but of late, SAP has also switched to BPMN. So SAP itself also uses BPMN for modeling its processes. Now, what I'm going to talk about is AI applications in business process management. So a lot of that work can be described under the broad umbrella of process analytics. So a lot of that work is about analyzing data that is generated by the execution of a business process. So you execute a business process either manually, so that's the basis for the whole BPO industry that many of us are familiar with. It's obviously it's been a very big thing in India, but it's also what happens when you execute a process. So when you do something standard, such as sign up for a SIM card or apply for a home loan from a bank, what happens behind the scenes is the execution of a business process. Now, traditionally, business processes have been manually executed. With the advent of companies like SAP, there was some modicum of tool support, IT tool support for the execution of business processes. But more recently, there is a big trend towards something called robotic process automation. And unfortunately, a lot of people in industry refer to it as robotics, and that causes all manner of confusion because it's not about building robots of any kind. It's robotics in the sense of building chatbots or software agents which help automate what would be traditionally human-mediated business process execution. So the value proposition to most companies is, instead of investing a vast amount of money in call centers and outsourcing that work and so on, you can now automate the execution of many of these processes using a combination of chatbots for human interfacing and for generic intelligent agents for doing some of the back-end work. So so that's the state of play right now, right? So there's the RPA industry is huge. There are many good, relatively small RPA players in industry in India that I know of. The world's biggest RPA company called UiPath is originally from Romania, but it's now a unicorn. It has a massive market valuation and so on. But there are other major players, Automation Anywhere, Blue Prism, some of the big names. But these days, Microsoft has a RPA product. Sooner or later, IBM will have one. So it's people are predicting it's very soon going to be a $9 billion US per annum industry sector. And it's built around the idea of throwing AI into the business of executing business processes. But taking a step back, we will start the story by looking at the data that is generated by the execution of a business process. Now, business processes, whenever they're executed or supported by some kind of computer machinery, there is a log of the execution of the business process that you can always extract from the back end. So sometimes these logs are called process logs, and they will say things like, this task was done at this time by this person, and it was about that insurance claim, if you're talking about an insurance claim handling process, or it was about that home loan application and things of that sort. So that's often called a process log, a collection of these entries that say this task was done at this time by this person. You can also have event logs, which log events. So that says that, an event log will say at 10 o'clock in the morning, we logged that a certain server went down. At 11 o'clock, we logged that another server went down. At 12 o'clock in the morning, we logged that the first server was brought back up by tech support. So these are all events. These are not the execution of business process tasks, but these are external things that have happened, but we log them. So we have a timestamp for each of these. So we have process logs and we have event logs. But then we also have provisioning logs, which tell us what resources we deployed for the execution of a business process and at what time. We can have context logs, which tells us what was the operating context like at the time that certain tasks were executed. We can even have these things called decision logs, which we have worked with, which say that for each decision that my organization took, I have kept a record of what the alternatives were and the alternative that I picked. So every time I issue a contract, I keep track of who the bidders were and what the winning bidder was. So I keep a log of this, and this can be subjected to all kinds of forensic analysis for the purposes of transparency, where it can also be used for ensuring that we know that we are being consistent in the application of certain criteria in taking certain decisions and so on. So this is the general idea of process analytics. Now, one good way to understand how this sort of thing delivers value is if you think about clinical processes. So a clinical process is where you are logging all those things that we just talked about, but the process in question is the treatment process for a patient. So now one of the things that we can do with process analytics with clinical processes is that we can identify what sequences of medical interventions led to a good outcome. For those patients who we managed to cure, what did we do to them? And for those patients that we couldn't cure, what was done in their cases because that's like a negative example. It's like an anti-pattern. It's something that I want to avoid. There's also the business of prediction, or sometimes called predictive analytics, which is tell me, I'm looking at a patient who's partway through the treatment program. Now tell me how things will work out for this patient. There's also, again, forensic analysis. This patient didn't respond very well to this treatment. Why was the case? Why was it that the patient didn't respond well to the treatment? What should I do with the patient? Prescriptive analytics. And there are richer versions of these questions as well. There are similar questions that apply in generic business contexts. So what combination of resources should I deploy for a business process? What combinations of resources worked well in the past? What combinations didn't work well in the past? And so on. Now, let me tell you the basic story. So the basic story is something called process mining. Now, in the late 1990s, a whole bunch of people came up independently with the idea that it might be possible to reverse engineer a process model from a process log. Now, that's all. So if you think of a process model as like a flow chart, and a process log is just a log of what was done. So here on this slide, you can see a process log at the bottom. It says for case 1, task 1, I did task 1 at 10 o'clock in the morning, and R1 was the human resource, the person who did task 1 at 10 o'clock. For case 1, again, task 2 was done at 5 minutes past 10. It was also done by this employee R1. For case 1, task 4 was done at 10:15, and it was done by a different employee called R2, and so on. So this is the nature of a process log. Now, in some sense, what we were looking at then is, if we talk about the idea of reverse engineering a flow chart from a log like this, we're essentially mining the algorithm. So we're saying that from the data of past executions of this problem-solving procedure, i.e. this algorithm, I can figure out what the algorithm was. So I'm trying to generate an explanation for the data I'm looking at. I'm saying, well, this data could only be generated by the execution of this algorithm represented by this flowchart or by this business process model. Right? So in we don't have to go into the details of the business process modeling notation, but this is a start event, this is an end event. T1, T2, T3, T4 are tasks. These diamonds are decision gateways. In particular, these are XOR decision gateways, exclusive OR decisions, right? You either go on the upper path or the lower path and so on. So in particular, this business process model is what process mining would reverse engineer from this log here. So this is the idea of reverse engineering process designs or process models from execution data of actual processes. So amongst other things, this is a great way to save effort, right? So instead of asking people to draw business process models, which is often very tedious, cumbersome, takes a lot of time, takes a lot of money, it's easier and much more efficient to put a process mining module on top of past execution data and automatically generating a business process model which explains that data. Right? So this is what is routinely done. So talking about the history of this, in the late 1990s, a whole bunch of authors wrote papers independently, having come up with some version of this general idea. Then one particular academic took this a whole lot further, who continued to work on this topic and published huge volumes of work on the question of process mining. This was a Dutch academic called Wil van der Aalst. These days, he holds a Alexander von Humboldt professorship at RWTH Aachen, which is a university in Germany. It's a highly prestigious professorship. So Wil van der Aalst sort of single-handedly made the thing popular. He wrote the most papers about it and so on. Now, interestingly, in his research group, there were a few PhD graduates who said, we can commercialize this idea and we can make good money from it. A couple of them tried, but their consulting organizations never grew very big. They're still good, they have products and so on, but they never grew very big. Now, fast forward to about 7 years back, 3 MBA students from the Technical University of Munich, MBA students, not computer scientists, not students of this Dutch professor I was talking about, came up with the idea that they would create a startup and house it in the, here's SAP again, in the SAP startup incubator. And they would sell easy to use process mining technology. So that company is nowadays a very large company. They grew rapidly from 3 people to 400 in the space of a few years. They are now treated as a unicorn, and that company is called Celonis. So this is now very big news in industry. Celonis, it charges $500,000 US for process mining one business process. So they charge a lot of money for doing the kind of analytics that we just talked about. So this is Celonis, and there are a few copycat entities of Celonis. The most recent piece of trade news is that a very large business process management software vendor called ServiceNow has joined forces with Celonis, and they're going to collaboratively deliver both process modeling, process management, process execution, and process mining all at the same time. So I don't know if I can convey all of the excitement around these themes in a very short talk, but the idea is that there is, this is, if nothing else, very big business. There's lots of money changing hands. It's enormously commercially viable work, but it is very strongly rooted in academic fundamentals. And that's what makes it, interesting and exciting to be working on. So I'm going to talk about some extensions to process analytics that we have developed in my lab. So the first thing that I'm going to talk about is the idea of process post conditions. Now, think for a minute about how a doctor thinks about a patient. So a doctor is preparing a patient for surgery. So the doctor is going to not think along the lines of, first I'm going to administer a blood pressure lowering drug X, then I'm going to administer a blood sugar lowering drug Y. Although that's how it looks like, that's what the doctor seems to be doing. What the doctor is actually saying is, first I need to lower this patient's blood pressure, and then I need to lower this patient's blood glucose level. So the doctor is thinking not in terms of the name of the task or the specific activity involved, which is give drug X, give drug Y, and so on. The doctor is thinking along the lines of the effects that the doctor wants to achieve in the patient. So the first effect the doctor wants to achieve is that the doctor wants to reduce the patient's blood pressure. The second effect the doctor wants to achieve is reduce the patient's blood sugar. So then the question is a process model the right way to describe what's happening here? It turns out it isn't, because a process modeling notation of the kind where you see things like this, the tasks will be like administer drug X, administer drug Y, and so on and so forth. But what we are really talking about are the effects we want to achieve with these tasks. So what clinicians often want to do is discover the effects of executing a medical protocol or a clinical process. And also there's very interesting questions around checking for contraindicated clinical processes being applied to the same patient. We've seen many, many examples in our work with clinicians where different medical specialties are treating the same patient. Somebody has you might have a patient who's being treated for kidney failure and cancer at the same time. And there are many, many cases where what you do for treating kidney failure actually works against what you want to do for treating the cancer. Sometimes you want to increase the level of a hormone in one treatment protocol, and you want to decrease the level of the same hormone in the other treatment protocol. In general, checking for these interactions can be left to the humans, but then you have to rely on what are called medical boards. So these clinicians sometimes form committees and they consult each other in what to do with a certain patient and so on. So you can leave it to these kinds of entities and hope that they will catch these interactions, these negative interactions, but they often don't. So then the question is, can I automate this? So now automation is very tricky in the following sense. If you look at the US National Institutes of Health, they have a repository of essentially clinical processes. It's a website called guidelines.gov. So these are clinical guidelines, which are textually, written in English text, textual descriptions of clinical business processes. And now the question is, how many of these do they have? They have 17,000 distinct guidelines for different diseases. So essentially, they're doing business with 17,000 different diseases. Now think of the combinatorial complexity of the problem. I wanted to talk about possible interactions between pairs of diseases. Take any two at a time. So 17,000 choose 2, plus 17,000 choose 3, plus 17,000 choose 4, all the way up to 17,000 choose 16,999. So that's the complexity of what I would have to consider if I wanted to fully automate the process of checking whether one treatment protocol will work against another treatment protocol. So that's very, very hard. That's impossible to do. And so the next best thing to do is to work with these effects, these post conditions. So what we have done over a period of almost 15 years is we have worked on a tool which allows us to, let me just quickly show you what the tool does. So it's a tool called Processeer, which allows you to look at a business process, point your cursor at a certain point in the business process, and ask the question, if I execute the business process up to here, what will have happened? What will the effects have been? Right? So what the tool does is it gives you a sensible answer to this question. So I can take my cursor anywhere in the business process and it will give me an answer to that same question. Now, what we originally started doing is we built the tool based on lots of assumptions about what the process modeler will have to encode by way of knowledge to support this answer, right? To support the generation of this answer. And that looked like a pretty forbidding task. I mean, people often don't even want to model processes because they're too complex. And then you ask them not only to model processes, but also to model the post conditions of every task, the effects, and so on. It gets very complicated. So then over a period of time, we started thinking about the question of, by the way, this is an example of a actual clinical process of what to do in the case of head injury. And if you ask a doctor, which we did, what are the effects of one particular activity, one particular task on the patient? This is a logic representation of the effects. And you can see it's incredibly complex just for a single task. And you can have this for many, many such tasks. So what we were looking at is the idea that can I automatically mine these post conditions? Can I mine these post conditions from those logs that we were talking about? And in the end, we came up with a solution which actually allows us to do that. So we now have a tool which allows us to mine the post conditions of a task based on the standard execution logs that I was talking about. Now, I won't go into the details of exactly how the mining happens, but I will offer a little example to give you the intuition of what is involved. And curiously, that intuition goes against the generally accepted philosophy which in machine learning, which says that, correlation does not imply causation. Just because I see sunlight coming into my room at sunrise does not mean that the act of sunlight coming into the room causes the sun to rise in the sky. In fact, it is the other way around, right? The sun rises in the sky, and that's why the sunlight comes into my room. So often correlation is confused with causation, and it should not be. But this exact intuition can be used in the case of post-condition mining in the following sense. So suppose I'm logging all my events. Right? So I'm executing a business process, and every time I execute a task, I also log what's happening afterwards and so on. Now, I notice a pattern which says that every time I do task T2, some event J seems to always happen every time I do task T2. So immediately or soon after I do task T2, I see event J. And this has happened many, many, many times. And something tells me then that maybe it's because I'm doing task T2 that event J is occurring. In other words, it's a common sense intuition that maybe the act of doing that task is causing that event to happen. So we leverage that intuition. We leverage the intuition that if I see in many different contexts with many different sorts of situations and other preceding and succeeding tasks, every time I do a certain task, a certain event happens, it must be the case that that task causes that event to happen. In other words, that event is a post-condition of the execution of that task. It's an effect. So based on that idea, we have developed a tool which allows you to automatically mine these post-conditions. Now that's kind of powerful and interesting because it allows us to do a whole bunch of things. So instead of relying on the human process modeler to write a whole bunch of knowledge in addition to building a process model to explain these things, we automatically acquired this kind of knowledge. So I'm going to take a brief 2-minute break, and I'll let you ask me a few questions. Did all of this make sense, and would you like to get a deeper explanation for any of these questions? If everybody is quiet, then I'm assuming it either made sense or everybody's asleep. Either way. What do you think, Dr. Sapra? Is everybody asleep? You're obviously not. Did you say something? Say again. No, I can't hear you. Anyway, if there's any question, I'll take it now, or I'll continue on the assumption that everybody understood what I talked about and it made perfect sense.
Your presentation is good. Nobody is responding. Even then, you are very well presentation. We are understanding it.
Okay, good. Glad to hear that. At least you've been awake, and I applaud you for staying awake. I know it's just after lunch in India, so people must be feeling sleepy after a good lunch, perhaps. Okay, so let me resume my screen sharing and continue where we left off. All right, so what I've talked about so far is the idea of task post-condition mining, right? So we developed this technology that allows you to do that, and it's extremely useful. It's also useful because we are able to do a lot of important business functions. So one of the big things that companies worry about in the context of business process management is something called compliance management, which is a huge industry that kind of grew out of nothing just after 2001, when there were two major financial sort of scandals, accounting scandals. One was around a company called Enron, another was around a company called WorldCom, both US companies. And as a consequence of bad accounting practices, the senior management of both companies went to jail. In fact, for natural language processing researchers, the email logs of Enron is publicly available on the web, and it's a rich source of information on which, a data repository on which you can do all kinds of good experiments. So the Enron email log is a very interesting data source. Compliance management became a big thing because the US Congress, as a direct result of these two financial scandals, they passed a piece of legislation called the Sarbanes-Oxley Act, or SOX, S-O-X. So that piece of legislation, which I had a PhD student who studied it in great detail from the perspective of business process compliance management. That piece of legislation, amongst other things, says that if your company is found to be doing funny accounting, then the CEO goes to jail. So suddenly it became not so attractive for people to become CEOs, because you ran the risk of, if you're a CEO of a large company and somebody somewhere does some funny accounting, it's you that goes to jail. So a lot of people were not interested in becoming CEO also. So the bigger question though is that, can we build IT tools that will make sure that at least by design, our business processes don't break the law? And then there are other kinds of tools which ensure that even as I'm executing the business process, I'm not breaking the law. So the law is encoded in the form of rules, which in AI we know very well how to manage. And then what we are doing is we are saying that so design time compliance checking says that by design the processes don't violate any rules, and runtime compliance checking says that by virtue of looking at a particular executing instance of a business process, each transaction that is being done does not violate any rule. Now, that last category of software is generally described as a BRMS, or a business rule management system. So these used to be very big some years back, and they're still in the market and still heavily used. There was a very classic example of how a business rule management system can simplify the act of changing business policies. So some of you might recall that I think around January or February 2003, one of the space shuttle missions, when it was coming back to Earth, it blew up upon re-entry into the Earth's atmosphere. And in that particular mission, there was a lady astronaut who was of Indian origin, Kalpana Chawla. So some of you might remember this. So when this space shuttle disaster happened, a lot of people in southwestern US, Texas and places like that, they woke up in the morning and found pieces of burning metal in their backyard. It's pieces of the space shuttle that had fallen onto their backyard. And some of these people went and put these things up for sale on eBay. Now for eBay, it was a public relations nightmare because they didn't want to be seen to be selling this kind of stuff, right? I mean, this is capitalizing on a human tragedy. So they wanted to quickly block these kinds of transactions on eBay. Now, traditionally, because of eBay's vast infrastructure of servers across the globe, you would have to go and do code fixes throughout that network of servers. It would take a long, long time. But fortunately, eBay was using a business rule management system. So they had to change one rule once. And more or less within a matter of minutes, that change was propagated throughout the global network of servers that eBay uses. And so very soon after this policy change, people who are trying to sell space shuttle debris on eBay were blocked, which is exactly what eBay wanted. So that's a side benefit of the idea of using a business rule management system, often something that I use in my classes to explain how this can be a very powerful tool. So now Business rule management systems can help check business process execution compliance, making sure they are within the law, but you can also look for business process design compliance using the kinds of things that I am talking about here. Okay, so I will move on to something else now. Let me see. So we talked about compliance checking, compliance resolution. There are other interesting things about lifecycle management, enterprise process architectures. If we had lots of time, I'd spend time talking about it, but we won't talk about it now. The AI sitting behind all of this involves this idea of state update. I'll briefly touch on this because it's an interesting AI technique. So the state update problem is the problem of deciding when you have a state that describes how things were before you executed an action. The problem is to decide what is the new state after I've done the action. So I'm in a room and it's a dark room. So my current state of the room is that it's dark. And then the action I perform is to switch on the light. So what is the new state of affairs? Well, in this extremely easy example, the new state of affairs is that my room is now well lit up because the light has been switched on. But I could have more complex situations where it isn't easy to predict exactly how the state will evolve. And so there are a lot of proposals in the AI literature on how you might do that. And so this is one example of the implementation of one of those proposals. And we have done a lot of work with that particular approach. It's called the possible worlds approach. So we've talked about the idea of effect mining. So I'm not going into the detail of it. Let me talk about something else now. So I'll talk about the idea of semantic monitoring and compensation, which is another very interesting application of AI technology in business process management. And if I can give you a brief sense of what that is in the next 9 minutes or so, I think I've achieved what I could have achieved in 50 minutes. So a large class of business processes that we execute are what could be best described as socio-technical processes, which is to say that these are processes where there are critical elements which are human mediated and critical elements which are machine or computer mediated. And classic examples of socio-technical systems are what you would see in a hospital, what you would see in military command and control, what you would see in air traffic control, and things of that sort. Now, one of the tricks to managing one of these socio-technical processes where there are both human components and there are machine components is that we have to monitor. We have to make sure that it's doing the right thing. Now, much of the technology that has been developed in business process management for process monitoring essentially focuses on just making sure that the right sequence is followed. So the business process model says first do T1, then do T2, then do T3. So I check that I'm actually doing that. So I do T1, then I do T2, and then I do T3. But sometimes I might be doing the right sequence of tasks, but I don't get the right effect. So consider the following example. So consider a clinical process. Now, it's quite common in many hospitals where there'll be a nurse's workstation, like a computer which the nurse uses, and there is a clinical process for each patient. And the computer basically tells the nurse, okay, it's 10 o'clock in the morning, give this patient this pill. So let's say for a particular patient, the clinical process instructs the nurse that for this patient, take a blood pressure reducing pill and give it to the patient. So the nurse then takes the pill in a little plastic container, a glass of water, goes to the bedside of the patient and says, here, take this pill. And then goes away thinking that, okay, the patient will take it, right? He will pop the pill in the mouth and drink it with a gulp of water. But suppose now the patient actually doesn't do that. The patient might have not properly popped the pill in the mouth or spat the pill out or didn't want to take it. For whatever reason, as far as the process execution engine is concerned, the task was done, but the actual effects were not achieved. Now, later in the afternoon, there is a task which is check the patient's blood pressure. And we check the patient's blood pressure and find that it's extremely high. So now we know that there's something has gone wrong. Now, there's a very interesting other question, which I'm not going to go into today, which is about how to diagnose what went wrong. Why is it that the patient's blood pressure is high? I mean, the normal sequence of activities, because I gave the patient the blood pressure pill in the morning, by the afternoon, the pressure should be at a certain level. And it isn't, it's high. So why is that the case? So there's that kind of question, which is process diagnostics, which you can worry about there. But the other question is, how do I fix it? So the fix obviously is, well, I went and asked the patient, and the patient says, yeah, I didn't take the pill this morning when you gave it to me. So then the question is, how do I fix this? So the easy fix is give the patient the pill now. Okay, you didn't take it in the morning, take it now. But maybe the patient is supposed to be going through a surgical procedure later in the afternoon, and you can't give the patient the pill right now. You should have a certain number of hours gap between taking the blood pressure pill and going through that surgical procedure, in which case we can't give the patient the pill now. And suddenly the whole plan, the treatment plan for that patient goes out through the window because things are delayed. We can't do the procedure now if we give the pill, but we can't do the procedure if the patient's blood pressure is high. So all kinds of hell breaks loose. So what is happening here, though, is the idea that every time we do a task, we not only need to check that we are doing the tasks in the right sequence, we also need to look at the semantics of the task. In other words, we need to understand the effects. Are we seeing the effects that we expect to see? So this is the idea behind the machinery that we built, which is the semantic monitoring machinery. So this is where you're checking each task, not only for whether the task is being executed in the right sequence, but also whether it's producing the expected post conditions. And so in our little example that we just talked about, we weren't getting the expected post condition, which was that, in the afternoon blood pressure check, the pressure should have been much lower than what it was. So if you see that, then you have to do a compensation task, which is some way of fixing matters. So something went wrong, now let's compensate for it by doing something to fix it. And so the compensation task is now the bigger question is, how do I position that compensation task? And the example I gave you shows how sometimes it can be very tricky. Sometimes it's very easy. You forgot it in the morning, so take it now. But sometimes it is the case that you can't take it now because there are other constraints at play. So then it becomes essentially an AI planning problem. So you have to create a plan which allows you to achieve the same goal, but with a different starting state. And there is a very interesting line of activity where you worry about that kind of thing, and you deal with the whole search space of possible ways of fixing a broken process. So that's something that might be interesting to you all. I want to give you a little taste of something else, something that we've done only in the last 3-4 years. Some of you might remember that around 2016, a company called DeepMind, which was eventually acquired by Google, played a world championship match in the game of Go with the world champion, who was a South Korean guy called Lee Sedol. So this computer-based Go playing system called AlphaGo played the world human Go champion in Seoul. There was a very famous episode, and in the end, what happened was that the computer-based system won, the human lost, and this became very famous. Now, this is not the first time that this has happened. When I was a PhD student at the University of Alberta, in my lab, they built what became the world checkers champion. So checkers is a game which is played a bit like chess, on a chessboard-like setting, but it's a simpler game than chess. For 35 years, there was one American professor of mathematics. He taught in a small college in Florida. His name was Marion Tinsley. So he had been the unbroken world checkers champion for 35 years. And then this program, it was called Chinook, it challenged him, well, the guy who wrote the program, who was a good friend of mine, he challenged Marion Tinsley to a championship match, which was held in, a championship was a series of matches. It was held in London, I think in the year 1991, sponsored by a big computer company in those days. Nowadays it's gone out of business. It was called Silicon Graphics. So in that championship, Marion Tinsley lost. And then there was a repeat championship face-off between the program and the human lost again. And then curiously, sadly, a couple of months later, Marion Tinsley fell ill, and after some more months, he died. And we used to kind of sadly comment on the fact that maybe he died because his whole faith in life and himself was shaken by the fact that a computer program came along and removed him from his perch, from his position as the world's champion in checkers. And so this has happened before. Now it's happened with checkers, and of course it happened much more recently with Go. Chess, it hasn't happened yet. Although in 1997, IBM fielded a chess playing computer called Deep Blue to play against the world chess champion at that time, Garry Kasparov. And in that tournament, Deep Blue defeated Garry Kasparov. Now, all of this is, tells us that, computer game playing algorithms have come a long way. They're very sophisticated, they're very smart. So what we did was we were looking at the idea of executing business processes. And we were saying that when a business process executes, in the worst case, the environment might conspire to prevent the business process from executing successfully. So that might happen because it's deliberately trying to block the business process, or it might be just the worst case scenario. In the worst case, the environment evolves in certain ways that makes it impossible for the business process to achieve its goals. Now, if that happens, how do you plan for the execution of your business process so that you can think of the best workarounds around whatever obstacles the environment might throw in your way? So we used game tree search algorithms to improve business process execution techniques, and that led to some very, very encouraging results. And we have published a series of papers on the topic. So it's a very interesting idea that you can take computer game playing techniques and apply it to robust execution of business processes. So that's another little example of interesting AI that can be done in the space of business process management. I think my time is now up. I've got the last couple of minutes to take questions from you. And so I'll stop sharing and I'll welcome questions.
Sir, no one is writing on the chat box.
No one is asking questions. Okay, I must have put everybody.
We are thankful to you. We are highly thankful to you for giving this type of presentation. It is a very valuable information that you have given. It is visible at the stages that information given by you. So we thanks to you for joining us and giving the presentation. Thanks a lot, sir.
Thank you.
Thank you, sir. On personally behalf of myself.
Sure. Thank you, Dr. Professor
Thank you,
Dixit.
sir.
Thanks. Okay. All right. Bye.